In this first video on subpopulations, I'll talk about why it's helpful to work with subpopulations, and also we'll look at comparing an overall population with a subpopulation in terms of why it's easier to create good models on specific subpopulations. One of the things that we need to do when we're working with the population is to realize that sometimes working with segments of the population or subpopulations can really be a big help. And so I'm going to take an example of doing this, and what we're going to start with is the single family homes example that we've been working with on one or two of our assignments. So I have my single family homes information here, and I've got it partitioned so it's ready to go. And what I'm showing you is I'm showing you the solution, and then I'll discuss how I got the solution. So I have a compound regression here that is calculated on this, and you'll notice that the root mean squared error is about 25,000. So that's really quite good, because in this model we have homes ranging from $200,000 to $700,000. How did we do this? Well, we did this by thinking about this data not as a single population, but thinking about it a set of subpopulations. Now here, when I ran the multiple linear regression on the top data before I broke it into subsets, you can see that the root mean squared error is about $59,000. So we had a lot of error, and that really is because there was so much diversity inside that. There are things, homes that are cheap homes, expensive homes, sort of middle of the road homes, homes with big lots, homes with little lots. That much diversity makes the models very hard to be very predictive in their accuracy. So let's look at some examples here so that we can see this data and look at it as the whole, and then we'll kind of look at one population to sort of see how much of a difference there is in one population. So here I've brought up the summary statistics on the entire set of data. And what you can see is we have bathrooms and bedrooms ranging from 1 to 11. We have, some of these are new on the market, some have been on the market for over 3 years. We have features is whether or not they have a den, whether they're on the cul-de-sac, where they have a laundry room and so forth. And so if they had any of those, I just gave them one for each one of those things that they had. We have a latitude and longitude. We have lots that range from essentially no lot, which probably means that the real estate agent didn't enter that in, up to almost 200 acres. And so we have a huge diversity of lots. Even though if we look at the histogram, you'll notice that you'll find that most of the lots are really down within that quarter acre to 1 acre range. We have prices ranging from $36,000 to basically $4 million. So we have very cheap homes up to very expensive homes. Square footage wise, we have teeny ones. This is just very small, up to mansions. 17,000 square feet is very large. Some of them were built from the 1800s. Some are brand new. This data was collected in 2012. And then over here, let's just look at one subpopulation. If you look at just the homes that were less than 200,000, then you'll notice that they're a lot less diverse. We have 1 to 5 bathrooms, 1 to 7 bedrooms. So these were 11 when we looked at the entire population. Even the days of the market are less. And then we also have the lots. There are no lots larger than 2 acres, basically, in this small set. We have prices ranging again from 36 up to that 200,000 limit. And then we have square feet ranging from the teeny up to about 5,000. So you'll notice that this is bounded here at 5,000. This is bounded at 200,000. And if we look over here, these were bounded at basically 4,017,000. And so we have a lot of diversity in here. But if we are able to segment the population into these very specific sets, then we have a lot better chance, or algorithm has a lot better chance of doing well. It has a smaller set to build its means and averages off of. There's not as much diversity, and there's a more homogeneous population for it to be able to see.